we have seen, the burners in a boiler provide the combustible mixture of air and fuel oil that is burned in the boiler furnace. As seen in this view of a typical burner mounted in a furnace wall, the burner's atomizer reduces the fuel oil to finely divided mist-like particles. That is, atomizes the fuel oil. Then the air doors and the bladed cone in the burner register mix these particles with air to form the combustible mixture. Although all burners perform these two functions, atomizing the oil and mixing it with air, different types of burners atomize the oil in different ways. Most burners are mechanical atomizing burners. Some mechanical atomizers are the pressure type. There is also a return flow pressure atomizer. Another mechanical atomizer is the rotary cup type. A few burners use steam atomizers. In this film, we will see how these different types of burners work. The forced draft blowers send a strong blast of air to the burner. The fuel oil pump sends the oil through the heater where the oil is heated to give it good flow qualities. Then the oil is pumped to the burner. This simplified cutaway of the burner shows how the fuel oil is forced through the burner barrel to the atomizer nozzle, where a series of passages guide the oil to the sprayer plate. The sprayer plate makes the oil rotate at high speed, breaking up the oil into particles. The oil leaves the atomizer as a hollow, mist-like cone or spray. Meantime, in the burner register, air provided by the forced draft blower is given a rapid rotating motion by the air doors and bladed cone and mixed with the oil spray. The mixture of oil and air enters the furnace where combustion takes place. The diffuser prevents the air blast from blowing the flame from the atomizer tip. Now let's see the action of the sprayer plate in more detail in an exploded view. You can see how the oil passages in the atomizer nozzle guide the oil into the slots of the sprayer plate. How the slots give the oil a very rapid whirling motion in the whirling chamber. And how the whirling oil emerges from the sprayer plate orifice or opening as a hollow cone of mist-like oil particles. You control the firing rate of the burner by varying the amount of fuel oil flowing through the burner. Of course, you must make corresponding changes in the amount of air reaching the burner when you change the amount of fuel oil. When you increase the pump pressure on the fuel oil line, you increase the quantity of oil going through the burner. When you decrease the pressure, you decrease the quantity of oil. However, when you want an increase in the firing rate, the sprayer plate in use at the time may have too small a capacity. That is, too small an opening to provide the necessary quantity of oil, even with oil pressure at maximum. You must substitute a plate with a larger capacity. When you want a decreased firing rate, the sprayer plate's capacity may be too large to properly atomize the reduced quantity of oil. You must substitute a plate with a smaller capacity. Frequent changes are necessary because the operating range of a given sprayer plate is very limited. Controlling the forced draft blowers is the principal method of controlling the quantity of air reaching the burner. For example, to increase the air a moderate amount, you increase the speed of the blower in service. Or, if even more air is needed, you cut in another blower. You can make minor adjustments in the air supply with the air doors. In this type burner, only part of the oil that goes through the burner is actually burned. The remainder returns to the fuel oil pump. Air doors and a bladed cone give the whirling motion to the air that enters the register to mix with the oil, as in the burner seen previously. The oil, heated and under pressure, is forced through the inner tube of the burner barrel to the sprayer plate, where the oil is rotated in the whirling chamber. The oil leaves through the sprayer plate orifice. Centrifugal force sends some of the oil into the return line and back to the fuel oil pump. The remaining oil continues through the orifice into the furnace. At the burner's maximum firing rate, practically all the oil enters the furnace. At the minimum firing rate, practically all the oil returns to the pump. In controlling the fuel supply to the burner, you keep the pressure on the oil entering the burner constant and at the maximum for the system. You vary the pressure on the return line. When you close down on the return line valve, less oil can get through. As a result, the pressure builds up in the return line. This greater pressure forces more oil into the furnace than before. When you open up on the valve passes more oil and return line pressure drops. Less oil enters the furnace. Varying the speed and number of the forced draft blowers is the principal method of controlling the burner air supply. You can make limited adjustments to the air supply with the air doors. In the rotary cup burner, a fan or blower is mounted on a hollow steel shaft. An electric motor or steam turbine turns the shaft and blower at high speed, providing a blast of air around the burner nozzle. The oil, under low pressure, enters through a stationary fuel oil tube inside the rotating hollow shaft and is discharged into the rotating atomizing cup. Centrifugal action forces the oil against the inner surface of the atomizing cup and causes the oil to leave the rim as a hollow cone. The meeting of the oil and the air from the blower further atomizes the oil. Additional air needed for proper combustion enters through an air door in the furnace wall. As in all burners, you control the firing rate by controlling the amount of fuel oil and air going to the burner. The steam atomizing burner is similar in many respects to mechanical atomizing burners. It has an air register with diffuser, bladed cone, and air doors. However, the barrel of the burner has passages for both fuel oil and steam. High-pressure steam passes through the central passage in the burner barrel, while oil, under low pressure, passes along outer passages. The steam heats the oil. The steam and oil mix in the sprayer plate. The mixture passes through openings or jets in the plate and emerges as a fine mist. Meantime, the air from the forced draft blowers is entering the register and mixing with the oil spray. Control of the burner involves regulating the air, oil, and steam supply. Regulate oil pressure to regulate the quantity of oil. When you increase or decrease oil pressure, you must change the steam pressure correspondingly to get good atomization. You must also change the sprayer plate in the burner if the capacity of the plate is incorrect for the new firing rate. As with most burners, you adjust the speed of the blowers and the number in service to control the air supply. In burners with mechanical atomizers of the pressure type, the sprayer plate atomizes the oil, heated and under pressure. The register gives the blast of air from the blower a rotating motion and mixes the air with the oil. You vary the pressure on the oil supply line to control the amount of oil entering the furnace. To control the amount of air entering the furnace, you vary the speed and number of the forced draft blowers. In the return flow burner, you vary the pressure on the return oil line to control the amount of oil entering the furnace. In the rotating cup burner, the action of the rotating cup and the air from the blower atomizes the oil. Additional air enters through the damper door. In the steam atomizer, oil under low pressure is heated by the steam passing through the barrel and is atomized at the sprayer plate. The register gives the air from the blower a rotating motion and mixes the air with the oil. You regulate oil pressure to control the oil supply and vary steam pressure with oil pressure. You vary the speed and the number of blowers to control the air supply. Study your official Navy publications for more detailed information about the type of burners in your ship.